And so next up we have Brian Cronin. Welcome.
Thank you for having me.
Yeah, you're here to talk about Monster Train, which very exciting.
Yeah, and I also hope to take part in a Boonstorm someday. I think that's something
Right?
we'll have to institute at Shiny Shoe.
I like that. All right, take it away, Brian.
All right, welcome to Monster Train Off the Rails, lessons learned from Monster Train development. Just a heads up, I'm an engineer. This talk is more on the engineer side rather than the design side, but as anybody who works in video games knows, they're often very much dependent on each other. So I just want to put that out there. I first want to thank the conference organizers and really the whole roguelike celebration community. I think Monster Train wouldn't have turned out to be the game it was without this conference. We benefited in a lot of indirect ways, I'm sure. And I'm also grateful to contribute. So my name is Brian Cronin. I've been working in games for about 16 years. I was one of the gameplay engineers on Monster Train. I also did the original architecture on the prototype that turned into what we shipped. So I'm to blame for a lot of the mistakes we made. I've also contributed to some of the design of a lot of the cards and artifacts of the few of the clans. And here's just a selection of some of the other games I've worked on over the years. So for anybody who might not know, I'm just going to briefly explain what Monster Train is all about. So it's a card-based deck builder. You start off with a bunch of kind of junky cards, and then you play through battles. You get new cards that are better. You upgrade your cards, get rid of the old cards. It's that sort of dynamic. It has a roguelike run structure. I'm not totally clear on the difference between a roguelite and a roguelike, but I would guess this is more on the roguelite side of the aisle. It's so you go through these battles with your deck, improving it between getting upgrades, getting more gold, all sorts of things you could do between the battles. And you go through a run. If you lose, then you have to restart the whole run. So it's that sort of structure. It has a very expansive meta progression system. So it's something that players really enjoy about the game. This is the log book, and it tracks what cards you've unlocked, where you are on the Covenant rank, which is kind of an increasing challenge system. There's all sorts of things you can unlock and progress on this. So this is something that players really enjoy about the game. And I'd also say something special about Monster Train. It has a pretty wild power curve. So on the top here, you can see cards from the first deck builder called Dominion. And it's kind of a, you base a card, you get 1 gold. And then an upgraded version of that for 3 money, you get 2 gold with the woodcutter there. In Monster Train, bottom left, Torch is kind of our basic damage card. For 1, what we call Ember, it's kind of like mana or energy. For 1 Ember, you deal 2 damage to a target of your choice. Or for 3 Ember, you could deal 100 piercing damage to all friendly and enemy units. So we really play with the power scale is just a little bit wild in the game, and something that also players really enjoy. And we also have a pretty extensive upgrade system. So throughout the run, players can apply all sorts of upgrades to their units and their spells to just make them better, make them do different things. In this example, they greatly decreased the cost of this unit. They made it smaller. They increased the damage output, all sorts of things that people are able to do through the upgrade system to really customize their run. And while we built Monster Train using Unity, this talk does not focus on Unity in particular. The principles apply to any game engine, but there will be some screenshots of Unity, so just a heads up. And it was released by Shiny Shoe and Good Shepherd Entertainment in May of 2020, with a Switch release in August of this year. So these are the lessons. I'm not going to go through all of them now, but just to give you, if you want some spoilers, there's 4 lessons I'm going to cover here. The first is that the prototype will become the product. So I think we've all heard this in our career. We've told ourselves this many times. It is just a prototype. We're definitely going to throw this out. Don't worry. We're going to hack things. We're just going to make it work and iterate quickly. And everyone knows this is a big lie. It's all lies. And that was also the case with Monster Train. So this is the original version of Monster Train. For people that have played the game, you're going to notice some similarities. There's 3 kind of lanes or rooms of combat that happen at the same time. You have cards that, in this case, are monsters you play down on the right side of the screen. There's also spells. The big difference here is that this version was real-time. When we first were thinking of Monster Train, we were thinking of it as a real-time game. These graphics were all just temporary, obviously. This is all prototyping. So the energy kind of ticks up at a fixed rate. Enemy spawn, combat happens at a fixed rate. That was how we originally thought about the game. Eventually, we moved off of that, and this is kind of the final version of the game here, which is a turn-based, kind of more traditional card game. But a lot of the code that drives this prototype exists in the final version. So we just kept building on top of what we created. That led to a lot of interesting problems, as my sort of generic Google image search for problems here indicates. So one problem we had, and again, sorry, this is more engineer focused. There are a lot of things in the talk that are not, but I am an engineer. So we took advantage of coroutines. And so for folks who might not be aware, a coroutine basically lets you express code that would happen over time inside of one kind of sequence or one function. So in this example, a unit is taking damage. I shouldn't mention this isn't real Monster Train code. I just kind of put up a simple example. Units taking damage, we're going to play an animation, then we're going to pause for 0.8 seconds. If they die, we're going to resolve a trigger. Maybe they explode, and then we're going to do another animation. So in total, this whole sequence took 2 seconds, and we expressed it all in one place, which is really handy because it's very easy to track what's happening. It's like a Lego instructions: 1, 2, 3, 4. It's all in one place on one page. The logic is very easy to track. You have other ways to express this sort of logic. You might have an event system, and that has its own advantages. But one of the biggest disadvantages of that is logic is all split out all over the place. So you don't have it all kind of expressed in one handy location. So for prototyping, coroutines make a lot of sense, and coroutines have their place in other areas too, but we definitely were a little overzealous with them. So the big disadvantage is there's no separation of concern. All of your UI and input and sound effects and game logic are all bundled together in one place. This led to a few problems. The primary problem it led to was how we did damage previews. So this was really important for our game. The combat rules are pretty simple, but when you start adding a lot of units and a lot of status effects, a lot of artifacts into play, it could be confusing to figure out how it's going to resolve. So we implemented damage previews, which is that little red X there I'm mousing over. And when it shows you, the X shows you that unit's going to die. But if I play a spell to kill one of the enemies here, it changes the equation. And now my unit on the left is going to take 15 damage while I'm going to kill one of the units on the right. So this is a very handy thing. This is basically necessary for us to ship the game, something players really enjoy about Monster Train, especially as you start getting more and more complicated cards and units. And to implement this, ideally, you would have a very deterministic simulation. So for folks who might not have heard that word in this context, the idea is, if I have this red domino here at the top and I knock it over, eventually the green domino on the far right is going to fall down. And that's going to happen every single time I push the red domino over. There's a lot of reasons why you might not have a deterministic simulation. You might have random number generation in there. You might be using floating point values that compute differently on different platforms. There's all sorts of other reasons. And this is something to get right. You kind of need to, at the start, you need to intentionally shoot for a deterministic simulation. And we didn't really do that. So as a result, we kind of just ran, our entire game loop was run on kind of a giant coroutine. And we had a lot of exceptions in that coroutine. This code's all over the place here, but if we're doing a sound effect, you don't want to do that in preview mode. You don't want to show a warning message on a screen in preview mode. So we had a lot of exceptions. This took a lot of time to get working correctly. We eventually did, but it was a lot of work. Another problem was just how do we represent cards? And that leads me to my next lesson, is that cards are basically their own programming language. So I love cards. Cards are awesome. I think anybody who has played card games loves card games. You see a binder full of cards and it just gets the wheel spinning. You just get really excited to think about all the synergies, interaction points. Cards are awesome. And I fell in love with cards with this game called Netrunner, which released in 2012. I'm sure there's some fans out in the audience who are getting those feelings looking at these cards. I know I do. But this was going to be my first digital card game, at least my first big digital card game. So, I was going into this with the prototype of how do I architect a card game? How do I represent a card in a way that a designer can manipulate? And I'm speaking mostly of kind of technical representation here, not necessarily the design of the cards themselves. So I didn't know how to do that. And I was looking online. I tried to figure out, how does Hearthstone do it? Or how do other games represent their cards? And there's surprisingly little information out there. So I wanted to kind of show how we do it, talk about what I think is good about this and what we got wrong, and help spread some knowledge of how you might build a card game. So I want to break down a card to show you how it works in our game. So this is Torch. talked about before. It costs 1 energy to play, 1 ember, as we call it, and deals 2 damage to a target of your choice. So here we go. Some basic information here, the name of the card, we have description. We had kind of a handy system where we could kind of hook into the effects. So in this case, it deals 2 damage. If we change the number to 3 or 1 later, all the card text will just dynamically update, which is really handy because we shipped the game in a number of different languages. So we don't have to retranslate just by changing numbers, which change all the time. You have some kind of other meta information here, what type of card it is, etc. This is the bulk of what I want to talk about, and this is the card effect, what the card's doing. And there's a lot of information here, and a lot of these parameters are not actually used for this effect, so I'm going to trim it down to what's necessary here. So card effect damage, this is what the card's doing. It's doing damage. We use card effect damage all over the place. This is basically a C# file, card effect damage.cs. It's just a script. Target mode, there's all sorts of target modes in the game. This one is just what character you drop the card on. Should test, I'm not going to worry about that for right now. And param int, well, I'm going to do 2 damage. So the param int was very contextual to the card effect. And then at the bottom, there's some other kind of meta information of what class it's a part of, when it unlocks, etc. So at a very high level, this is sort of how the logic is. We have UI code that represents your hand of cards. When we detect that the player's dropping that on a unit, we try and play the card in our card manager. From there, we remove energy from the player manager. If they don't have the energy, they can't play the card. And then we just, in order, just down the list, resolve the card effects. So there's a lot of code here. We're mostly just going to focus on the highlighted bit. At the top, we're computing the damage, which in this case is just going to be 2. But as you can imagine, we have a lot of different ways to compute damage. There's some sound effect code. And then ultimately, we're going to iterate over the targets. In this example, there's just going to be 1 target, but there are cards that target multiple units. And we're going to apply damage to that target through our combat manager. So this overall architecture worked fine for a long time. We had a lot of cards that just sort of did unrelated linear things, deal damage, draw a card, do this. But it really broke down when effects were dependent on each other and when they were non-linear, so when there was scaling involved. So as an example of that, I'll break down this card, Vent. So this is an X cost card. What that means is it's going to spend all your remaining Ember in the turn, and it's going to scale the effect. So deal 2x damage to enemy units. If you had 3 Ember, deal 6 damage to enemy units. So the way we do this is we have something called card traits. And there was a lot of card traits in the game. Some of them were visible, like do piercing damage. It would ignore armor. This card trait was invisible, and it was just responsible for hooking up this X with the effect. So this is saying do 2 times the played cost of this card this turn, which is kind of how it's hooked up. But going into that, card trait scaling add damage, there's a computation to get that bonus damage, that extra damage. I'm not going to go into that, but it just had a way to kind of query those parameters and determine your extra damage. And the way this worked is there was this function in our character class, calculate bonus damage. And if there was a card responsible for doing this damage, we would iterate through its traits, and we would allow those traits to modify the damage. So this is how it worked. And the big problem here, in my opinion, is that the behavior was very implicit in code. So the designer didn't have a lot of control over things. And as a result, we had to kind of custom write a lot of card traits, a lot of card effects even. In some cases for very specific cards. We had some cards where basically me or one of the other engineers was writing custom code to support that card. And that wasn't great. So in my mind, the solution, or I shouldn't say solution, maybe an improvement would be to use the idea of a kind of domain-specific action graph. So this is not for Monster Train, but this is one way it might look. And I wanted to kind of go into depth on a little bit through this example. So this is another Monster Train card called Awoken's Rail Spike. Each of the clans had their own rail spike. It's a train game. It's X cost. It has consume, so it can only be played once per battle. And it draws X cards and applies -1 cost to those cards. So a few different things going on here. I wanted to see how we might represent this in a graph. So the green nodes here represent control flow. So we're going to start at the entry. We're going to draw cards, upgrade them, and consume. So in draw cards, how many cards are we going to draw? Well, it's going to be based off the energy spent. These would be parameters that would be either dynamically determined, such as energy spent, or designer determined, such as upgrade data. So we're going to draw energy spent cards. What cards are we going to upgrade? Well, we're going to upgrade the cards that we drew. And what are we going to upgrade them with? We're going to upgrade them with a piece of data that the designer has hooked up. And then we're going to consume cards. And what cards are we going to consume? We're going to consume the card that was played. But this also could consume any other cards that we have, this card list idea. So what if we wanted to change this so that we draw one card for every card in the discard pile? It's a very simple change. So instead of drawing energy spent, we draw the discard pile size. So we might have deck info, which has all sorts of info. We might have the size of the draw pile, number of cards in hand, whatever. And if we wanted to scale, we could also do something like put a 2x multiplier between these two nodes. So now we're drawing 2 times the size of your discard pile. So this gives the designer a lot more leverage over how these effects resolve and allows the programmers to write more specific, simple nodes. So lesson 3 is that feedback and iteration are everything. Super important. We took advantage of a system I want to talk about. So in Monster Train, we have the system. It's here at the bottom left in black, beta, press F8 to give feedback. So this was visible throughout the whole beta. This system is actually still in the version of the game that is on Steam. So people could press F8. This little box is not visible, but it still works, and we still collect feedback to this day. So I'll show you how this looked. See if the video works. So you might like this card. It looks like a cool card. You want to give some feedback. You just tell us it's a card looks good. We like this type of feedback too. And you hit submit. And that's it. So from player perspective, it's that simple. So what's great about this is just no friction. They don't have to put in a username password. There's no alt tabbing to a website. It's just all right in the game. Very simple to give feedback. From our point of view, we have a Slack channel where all this feedback goes. And so, the post is some meta information about who sent it, maybe what run they were in, some high level information, and then the comment. And then in a thread, we have the log file, which is awesome. Might have some error messages in there. They might be out of memory, all sorts of things we could determine just by looking at the log file. We also have the save file. So while we didn't have deterministic battles, the game itself was deterministic between battles. Well, the battle itself was deterministic, but we couldn't go into the middle of the battle, I should say. But the save file would let us go to the start of the battle, which was great to help try and reproduce bugs in a lot of cases. They would kind of tell us what happened, and we'd be able to, through the log and through the save file, reproduce it oftentimes very easily. And we also get a screenshot of what they, so we could see the context to what their feedback is. So this was super awesome, super useful. It's something we're doing on other games we make. It's just an extremely useful system. So if phase 1 is collect valuable player feedback and phase 3 is profit, phase 2 is the most important, which is taking consistent action. So it sounds boring, but someone's got to go in there and read every piece of feedback and take action on it. So we actually had little reactions in Slack, little emoji reactions where we could say, oh, it's already filed in our in Jira, or this is not actually a bug. We had little kind of ways we could tag it to just communicate between us. But we had our producer would go and just go through the feedback every day and file it to someone in a Jira, or we'd at least evaluate all the feedback, every piece of feedback we got. So it's a lot of work, but it made Monster Train the game it is. I think this tool, more than anything, was the reason for our success, and at least any particular tool, I should say. So the lesson is collect and take action on all feedback. It's super good. And final lesson, mixing gameplay logic with presentation is fun until it's not. This is probably the bulk of what I'm interested in as an engineer, and a culmination of a lot of things I've been talking about in this talk. So here's an example of what a card might look like in code. Again, this is not necessarily Monster Train, but this isn't far off. It's sort of a simplified representation. So here we have a list of effects, things like draw a card, do damage. Here's a callback. So UI code might tell us to play the card. On play, we're going to do a sound effect. We're going to iterate over the effects and resolve them through our game effect manager. And then we're going to start an animation to discard the card. And when that animation completes, we'll discard it logically, and then we'll play a sound effect. So let's go dig into this and see what this does. This just has maintains lists of the piles. So the hand pile, the discard pile. We'd probably also want to draw a pile here. And a discard is removing it from hand and put it into the discard. So pretty simple. Now, what happens if eventually we want to have some card effects that do something special when the card is discarded? You can imagine a card that does damage when it's discarded. So we're going to go and discard. We're going to go and do a callback on the card to tell it it's been discarded. And we might want to do this because there might be a lot of different ways a card can ultimately get discarded. So we need to put it here just so it gets caught. So here we have a list of discard effects that the designer could hook up. These are special effects when the card is discarded. Many cards won't have anything. This card does something. And we're going to resolve those effects. Now, the thing about this that I'm trying to demonstrate is there's a lot of callbacks calling back it from managers into objects, back into managers. It's a lot of sort of like global access. And in a lot of ways, this is what the Monster Train code base looks like. And this is what a lot of games code bases look like. Pretty much every game I've worked on ultimately kind of devolves into this sort of thing. So I'm just proposing sort of an alternative to this. Because this, when you work on the game long enough, it kind of starts feeling like this. And I love this one. Do not touch any of these wires. I think, toward the end of Monster Train development, I started to feel that way. And, the designer wanted to make some change and, be kind of like a not great moment in some ways. And, it drives you wacky. You just start going wacky trying to figure out how everything's connected. So how do you make spaghetti? Well, in my opinion, it's the folly of mixing gameplay logic with animation, input, and UI. I love this GIF. So it's important to note that a lot of game engines kind of lead us down this road. They take our hand gently down the road as we walk with them. So this is a game object in Unity. Other game engines are responsible for this too. And the idea is like, logically, yeah, the game object is going to have a light on it. It's going to have a model. It's going to have like this movement logic. And you're just going to cram all that into one game object, which feels like the way you want to represent things. It makes a lot of sense, but it also leads to some bad patterns, I feel. So this is what I've been moving towards in some of our other projects, a project I'm doing on the side. This is kind of the structure. So the idea is you silo off. The gameplay logic is completely separate. So in this example, you have world state, which would represent just the data of maybe where units are, what status effects they have, where props are in your world. Any information about the state of the world and how it's changing is in this world state. And this doesn't have a whole lot of logic. This is just some basic logic to query the state. And then the world engine itself is responsible for modifying that state. And it does that through commands. So often player input are going to drive these commands. So a move unit command, play a card command, world command damage, do damage to a unit. So the world engine is going to process these commands and apply changes to the world state. And the output of that is world state changes. So this is going to tell us that a unit moved, that a card played, that a unit died. And it's important to note these are not one-to-one. So damage may or may not result in a unit death. So a world command may not actually result in any world state changes, or it might result in dozens. You might have heard this as model view controller. And under that model, world state would be the model. World engine would be the controller that's manipulating the model. And the view of that are these world state changes. So the way this would work is you would generate world commands from input. The world state changes would then drive your visuals and sound effects. So unit moving might result in footstep sounds through the sound system. A card played might do sound effects. There might be an achievement system, so we know if it's your 50th spell you've played, we can unlock an achievement. And a unit dying does sound effects, achievements. There's probably animation. So these systems can tune into particular world state changes while ignoring others. And it's also affords other opportunities. So it is relatively, well, I should say it's easier, not trivial. It's relatively easier to serialize the state. So you can output this to a save file, to JSON. It's also makes it a lot easier to do networking. You can serialize this over the network. It's isolated from all your visuals, sound effects. So in the Unity example, all of the game objects and all that would just be a view into this world state. So the world state itself would be completely isolated from Unity in that example. You might not even need to use Unity code at all. So a lot of great advantages, and I've been using this for a little over a year, and I'm very happy with how this, with the benefits that this has. So that's all I have for now. I think I talked a little bit too fast. This is my social on the bottom left, so Twitter @BrianG Cronin, and if you want to email me, if you have any questions, comments, nitpicks, whatever, you could reach out in either of those channels, and I'm happy to chat more about it. Thank you for your time.
Yeah, thank you. I mean, it didn't talk too fast because it just means we actually have time for a couple questions, which is great. Good because we have a few people definitely are very into this. Yeah, and Mark Ritter called the model view controller like one slide early.
Yeah, I knew someone would.
Yeah. Cool. So yeah, top question here from Foxtail David. Did you ever have to do any major code refactors due to a card effect not being possible in the current system?
Nothing that I remember, not like a major refactor. I mean, there was a lot of little refactors all the time. But we were sort of on a schedule that at some point didn't allow for big refactors. So we sort of just moved forward and made it work as best as we could. We probably did limit some of the cards we wanted to make because of technical limitations, which is always going to happen. And sometimes you have to make that trade-off.
Yeah. Okay, cool. People have been kind enough to upvote one of my questions enough. I don't feel as bad about asking it. I've found working sometimes with callbacks that they're trickier to debug and follow versus like direct calls. So did you have any techniques for dealing with the debug and kind of readability problems of a bunch of callbacks?
We definitely had those problems. I'm trying to think if we had any interesting techniques specifically with that. We did take advantage of extensive logging. So the company is really big on logging in general. So we have log categories, so you can kind of filter for gameplay stuff versus audio stuff. So a lot of the bugs that I would fix, the logging was really useful. And then it was just the sort of thing when you're working on a code base for around 2 years, you start to get intuition about it and it can track those callbacks a lot faster. But yeah, I'm an advocate for not doing callbacks now at all.
All right. Tacoberry has a good question. What's your favorite entry-level deck building game?
I think Dominion's great. If you're open to board games, Dominion was the first as far as I know. And other than that, I couldn't help but mention Slay the Spire in terms of a digital card game. I think Slay the Spire is really great. It definitely the earlier stages make it easier to jump into. But
I feel like you're not allowed to say it, but I think that Monster Train is actually a really good entry level deck builder. I think it's very understandable, and it ramps you up nicely with the different clans.
Oh, that's good to hear. Yeah, I most of my experience with the game is debugging late game stuff, so I'm used to very complicated board states, and
Yeah, no, I think it's pretty good in terms of early accessibility. Here's maybe one question from Oliver Uve that I'm interested in. Is there a reason you modify one state instead of a series of states? Which, if it was a series of states, maybe would that plug nicely into your feedback system? Or is there a reason why just having one is simpler?
Oh, I see. Kind of toward the end of the talk about the world states.
Yeah.
So, I mean, you could do it however you want. The games I've been working on recently, they're kind of, you have a world you're in, and then once that world's complete, like a run, you dispose of it. And so if you were doing a game that was, I don't know, like you're going between different buildings, you might have a world state per building, perhaps. You could structure it however you want. But the games I've been doing, it made sense to just have a single world state.
Right. And I guess would it have made sense on something like Monster Train to try and break up, like, here's the state of the monsters versus, what's in the hand versus what the upgrades are, or something like that?
I haven't thought about it, but I mean, it would have been a huge improvement for Monster Train to have that concept of a world state. I mean, there were so many things we could have done with that in hindsight. We always wanted to be able to like verify runs on the server side. So that was something we can never really do. So just to, find cheats and whatnot. That's one example. And then also just to be able to, we wanted to be able to save the battle in the middle of a battle. And that was something we could have done it, but it would have been a lot of work without kind of this mechanism.
Right. Cool. And yeah, maybe one more question from Hyper Gardens. How did you decide on the data format for those game entities? Because it feels like this infinite possibility space there that's hard to navigate. Of how do you actually like turn that into a nice packet? Especially with, it sounds like you didn't have to do a whole lot of refactoring of like, oops, we forgot something in that.
I see. So probably talking about how the cards were structured.
Yeah, I think like the card assets. Yeah, that data format.
Yeah, originally, to be honest, it was we're doing this prototype, and so I'm just going to do kind of something I've done before. Like I had worked on a card game before, but it was much smaller. So I'm going to do that. I liked the idea of the data pointing directly to the script that was going to resolve the game effect. So that seemed nice to me. So I did that. So there wasn't a lot of consideration ahead of time because I wasn't that worried about this rolling into production, but that did happen.
Right. Oh, and actually, I'll just quickly clarify because I see Oliver, you've put it in chat. When talking about the world states, it was actually a question of instead of having like a single world state that's modified over and over again, and you read, storing like snapshots of the world state as it goes so that you could look at kind of what was the state of the world throughout a whole run.
Yeah. Oh yeah, that sort of thing is totally possible with this method. There's a lot of things you could do in terms of networking where you need to do a rollback or whatever that you could have copies of it. So yeah, this mechanism, I think, allows for a lot of those things. It would just depend on your use case, what you wanted to do in particular.
Yeah, I think we just found the forbidden possibility of save scumming a deck building game.
Oh no, people do that in Monster Train all the time, and it's like
Yeah.
it's there's a mod that like makes it official in a way where you could kind of restart a battle to. But yeah,
Okay, yeah, that's cool. All right. Well, thank you so much. Really good questions, and yeah, awesome to have you. Thank you so much. I think that there was some conversation in chat. This is going to be a talk I think a lot of people come back and reference. Very practically helpful and enjoyable.
Yeah,
so.
I like practical stuff, and yeah, happy to talk. And especially if people have more thoughts on this, this is stuff I'm still learning myself and exploring. So happy to talk to other folks.
Yeah.